Okay, so good day to everyone, and welcome to our reinforcement discussion on data analysis, presentation of findings, and results interpretation. So we are already on the last part of finishing our paper, and it's really very important that we get to understand how are we going to process our data, okay? But starting off with its preparation, selecting the proper tools, then running it with reliable softwares, data analysis softwares, presenting it according to APA standards and according to the nature of its dissemination, and likewise coming up with the conclusions based on these findings, drafting your recommendations and completing the entire paper. Okay, so I want you to pay attention to this discussion as we go through the data analysis presentation and findings and results interpretation. So we begin with preliminary activities, and these preliminary activities would be very important, or these are crucial steps before data analysis. So in here, we have to remember that your data should be processable. I don't know if there's a term for such processable, but data is ready for processing. And there are several steps, or there are several activities that we do, okay, in data analysis or during data how to say this one, during data preparation. Okay, the first one is data cleaning. So data cleaning here involves identifying and correcting errors, inconsistencies, and missing values in the data set. So it is where we make sure that our data is ready for processing. It means complete. Um, it does not include any erroneous information. There is all of the given data are accurate, no outliers, okay? Because later on, if we do not clean our data prior to analysis, tendency is our results will not be valid. Okay, so what are some of the important tasks that you should include in data cleaning? Of course, we have removing duplicating entries, correcting typographical errors or coding errors, and then inputting missing values using appropriate techniques. So one of the common challenges here is not reaching your desired sample size. Now, it is one of the limitations in data gathering, especially if you do not meet your desired sample size. But you have to remember two factors why this would happen. So number one, it could be unavailability of your participants or your respondents. And another one could be like there are respondents or participants transformation to meet the assumptions of your statistical tests. Okay. Now, after you do the coding and the transformation, it's time for us now to data organize and document. Okay, so researchers should organize a data set in structured format that is conducive to analysis. So this may include creating a data dictionary or code book, or just a legend, a simple legend of assigning that specific numerical code with its interpretation or equivalent nominal data. Okay, and clear documentation is essential for ensuring transparency, reproducibility, and interpretation of the analysis results. All right. Now, so we're done with the three activities. Let's now proceed to the selection of your analytical technique. Now, usually I would recommend students, especially those in the basic education, to look for a statistical consultant to assist you guys with the right analytical technique. Though I do understand that during your methodology, especially on your data analysis plan, you have already initially identified what kind of data analysis tools that you're going to employ. But remember, if you will be very strict to that, there is the non-parametric and parametric assumptions. And just to have a quick recap, when data is large, continuous, randomly selected, and having reached or is normally distributed, then you go for a parametric test. But given all the limitations in terms of your methodology and your data collection, I would really suggest that non-parametric statistical tools will be utilized in terms of your data analysis plan. But remember, I've mentioned about the type of data, because the type of data actually plays an important role, especially when we decide what kind of statistical analysis that we use. So we have to remember the specific nature of the data that we collect. And just to have a quick recap, these data could either be continuous or discrete. So what's the difference between the two? Continuous data take infinite number of value that can occur within a population, while discrete data is usually limited. So from the name itself, continuous may go continuously, while your discrete data can only be categorized or only through a specific number or a specific range or a specific value for that matter. So let's take a look at more examples here. So when we say continuous data, they can be further categorized into interval or ratio data. So interval data is a measurement where the difference between the two variables does have meaning, while ratio data possesses the properties of interval data and has a clear definition of zero. So there is no negative value for ratio. So if there are negative values, then most likely you're dealing with interval data. But for categorical data, these are discrete. So examples are your nominal and your ordinal data. So nominal data is with no quantitative value. So you know this already. So this includes your categorical data, categorical variables like your sex, educational status, type of school, religion, ethnicity, all those kinds, where you subclassify them into categories. Then we have your ordinal data, data that has two or more categories which can be ranked, but the difference between the ranks may not be equally the same, unless if it's the same or if it has a value that it becomes interval. That's the main difference between your ordinal data and your interval data, the difference between the values and the meaning that these values have. Exclusively, if you just wanted to rank the values based on their quantity or based on the magnitude of the value, then you're dealing with ordinal data. But usually if you have equal differences and the differences would have its meaning, then you're dealing with interval data. All right. Now, remember the quantitative data analysis techniques may include descriptive statistics, inferential statistics, regression analysis, or multivariate analysis. So we will discuss that further later on. And then when you do qualitative data, okay, this may include content analysis, thematic analysis, grounded theory, and or narrative analysis. So the way you handle your data analysis would really depend on the nature of data that you have. So it's really good that you ask for a assistance or a professional guidance, particularly coming from an expert. Okay. Now, remember that you should ensure that they have the necessary knowledge, skills, and software tools to perform the selected analytical techniques effectively. Because if we really wanted to disseminate or publish our study, we cannot afford to have data that is not valid, not verified, and not properly analyzed. Okay. Also, it is important that we need to review our ethical considerations. Now, going back into your chapter 3, you have already designated all those ethical actions or ethical considerations particularly aligned in your study, and you must ensure that these data analysis procedures adhere to ethical guidelines. The ethical considerations would really depend on the type of involvement that you would have, especially if you're dealing with human participants, and to how much extent will they be involved in the study. So that would now ensure data security and integrity as well. Now, researchers should also consider the potential impact of their analysis on vulnerable or marginalized population and take steps to minimize harm. So just very simple concept on your ethical considerations is that you have to remember to minimize harm. As much as possible, we do not harm our participants. We do not make them feel they are being violated. Okay. And that would be captured if they would voluntarily participate in a study and when they sign your informed consent. Okay. Now, pilot testing is also part of data analysis, in which it involves conducting a preliminary analysis or trial run of the data analysis in order to identify any issues or challenges. Now, usually, if we have time, we do your pilot testing, and this would now include running your initial data and see how the data turn in, what results or findings they provide. And if there will be like outliers or there will be some inconsistencies, you may look back into your data set and probably go back again with your data collection to ensure that your data is consistent, valid, and accurate. Okay. Likewise, this pilot testing allows you, the researchers, to refine your analysis approach and make any necessary adjustments before analyzing the full data set. Okay. So I guess we are done with the preliminary activities or preliminary actions on our data analysis. And now let's proceed to the actual data analysis. So remember that data analysis is the process of bringing order, structure, and meaning to the collected data. So this is a very crucial part of your data analysis class, because in here, you are already trying to come up with the findings. Okay, and these findings will answer your question, your objectives, and this will now be the basis of your conclusion. So you cannot just play around with your data analysis, because it's very, very important. Okay, and it is a methodological approach to apply statistical techniques for describing, exhibiting, and evaluating the data. So in here, I'll be discussing more on the quantitative data analysis, and probably on our next video or next class, I'll be discussing on different types of qualitative data analysis, but generally we do your quantitative data analysis. So let's get it on. Okay. So generally, there are two ways to analyze our quantitative data. We have your descriptive statistics and your inferential statistics. But for part one, we will just be concentrating, or let's focus our attention with descriptive statistical analysis. So in here, from the name itself, descriptive, what is the goal of the statistical analysis? That is to describe. So in here, we are interested only with the surface level of analysis. We only wanted to look at the big picture of the data. What is it like to deal with these data, in a sense of creating the big picture, or coming up with what is the most common, what is what specific data or information that stands out from the rest. Okay, how is it distributed with the rest of the responses and all of these stuff. So we'll be learning all of these things. So remember that descriptive statistics are commonly used in exploratory data analysis to understand the distribution, central trend, tendency, and variability of the data. Now, class, I want you to take note of this: distribution, central tendency, and variability of the data. This is where we put our attention in descriptive statistical analysis. Okay, and remember that this is essential for summarizing the main characteristics of the data, identifying your outliers or anomalies, and informing subsequent inferential analysis. It also provides a foundation for understanding the underlying patterns and trends in the data set before making further interpretations or inferences. Okay, so what are the main components of our descriptive data statistics? So first, we have your percentage. Yes, and I think this is common already. You know how to do this. So percentage is part divided by the whole, and I'm sorry, this is not 10, but multiplied to 100. Okay, so for example, here's the data gathered by Purok A City High School administration regarding the number of grade 7 parents who opted to receive digital copies of learning modules. So in here, you would see that there are 4 sections. Okay, based on this table, you have 4 sections, total number of parents and the number of parents who opted to receive digital copies. And then we take a look here. So there for section 7A, 80% opted for digital copy and so on and so forth. Now, the good thing about percentage is that you don't really have to deal with the exact number. It's the easiest way to come up with the general picture of the data because it's part to whole. So you would know which part does this particular data stand in contrast with another. But it's not only limited to like 2 parts. It could be multiple parts. And then you would know the contrast of that distribution of data to another data. So it's really very interesting. Okay, and it's very easy to do. Now, let's proceed to the second, which is your mean or your average. So the mean score is the middlemost value of your list of values, and this can be obtained by adding all the values and divide the obtained sum of the number of the values. So what makes your mean or average different is that in here, you add all the scores or the value, and then after that, you divide as to how many of them or how many data did you add up. And that will now represent and then that would now determine the mean. Okay. So the mean score represents the average value of a set of scores or observation. Now, the easiest way that mean scores are actually useful is how we actually compare them, or how we this is where we compare our okay, it's how we compare our data set with the groups, and we would know which particular group performed better or which group has a higher score or something like that. And yeah, as what we've said, is calculated by summing up all the individual scores and dividing the sum by the total number of scores. Okay, so the mean provides a measure of the essential tendency and indicates a typical or representative value within your data set. So here is our formula: sum of all values divided by number of values. That's for your mean. We have ungrouped data here and grouped data. Okay, so usually the mean score that you produce or you were able to solve will have its equivalent interpretation. So in this case, like for example, the mean score for this item in a questionnaire, like a study where there is good lighting, got a mean score of 4.5. So that would actually be interpreted with a strongly agree verbal interpretation. Or if you would further analyze it, that would lead you into the understanding of a high level, okay, high level of mean, because it's very close to 5, as 5 is your closest number here. So the same goes also with the other items. If you're interested to look into the items and have derive the mean for these items, so that would actually be very helpful. So remember that when interpreting your mean, consider the research context and the specific variables being measured. How many scales do you have, for example, in a certain range for that matter? A high mean score suggests a larger magnitude or higher level of the measured variable, and a low mean score indicates a smaller magnitude or lower level of the measured variable. So these are just important considerations that you come up when driving out for your mean interpretation. Okay, now we are done with essential tendencies. Let's move on to standard deviation. Now, your standard deviation here, guys, class, actually is interested with how the data are spread out. Okay, again, the distribution of the data or how the data are spread out. Why does it matter? Because the more the data are spread out, the more that they are varying or they are variable. Okay, but if the data are close to the mean, it means they are cohesive and somehow would give us a more reliable, okay, a more reliable mean score. So that's the importance of your standard deviation. It is also a measure of dispersion or spread of data points around the mean, and it quantifies the degree of variability or deviation from the mean within a data set. Now, remember this. I want you to take note of these two things. Now, a low standard deviation suggests that data points are closely clustered around the mean, indicating greater consistency, while a high standard deviation indicates that data points are more spread out from the mean, reflecting greater variability or heterogeneity. Yes. So that's really the difference between the two. Okay. So it's important that you take note of how you're going to interpret your standard deviation here. Okay. Now, let me give you a simple example so that you would understand the value of your standard deviation. So for example, you're going to compare the two groups. Let's say a post-test score. Both groups got the same post-test score. Let's say they got a mean of 18.9. Oh, let's make it a little bit lower, like 16.9. Both groups got 16.9 as their mean score out of 20. Okay. Now you wanted to know whether which group really performed better, but just by looking at the mean, you'd probably say, oh, both groups performed the same because they have the same mean score, like 16.9. But little did you know that that 16.9 actually differs in terms of how spread the values are. Now, you look into the standard deviation, group A has a standard deviation of 0.72, while group B has a standard deviation of 1.87. So it's apparent that group B has a higher SD compared to your group A. Now, what does it mean? It means that group B performed a little bit varying because there might be some students who got perfect score, but there are also students who got very low scores. While for your A, it's very close, it's less than 1. So most likely it's the scores are very close to 16.9. So just by looking at the standard deviation, you'd probably say that, oh, I think group A performed better because they have a lower standard deviation, which indicates that it's more clustered and more consistent. All right, yes. So as what we had said here, a small standard deviation suggests that the data points are closely grouped, indicating less variability, while a large standard deviation implies that the data points are more widely spread, indicating greater variability. Now, let's not really go into the um, mathematical idea or the concept of the entire mean and standard deviation thing, but this is how you're going to solve that. And you would see here, okay, that the standard deviation would actually vary. Okay. All right. So this is what I was talking about about the mean a while ago. So if you have a strongly agree answer, you would get a numerical value of 5. And then we have here your mean range. Your mean range is how you're going to interpret your mean score. So your mean score is 1 to 1.80 for strongly disagree, 1.81 for do not agree, and that would have its equivalent interpretation as well. Now, this is an arbitrary interpretation. That means it's the researcher who did this ranges, but there are some tools that have its specific, okay, it has its specific mean range interpretation or data interpretation. So you can look into that because standardized tool would have their own data interpretation, and it's important that you review those standard interpretation when coming up with your own data interpretation as well. Now we will discuss further or more on the data interpretation, particularly on arbitrary ranges and standard tool interpretation so that we would know what's really the difference between the two. All right. So I guess that's it, class. Thank you so much for listening. Please hold on and watch for the second set of video because we'll be discussing on inferential statistics. Okay, we're going to talk about interpretation of your p-value and your hypothesis testing data, and also your data interpretation. So thank you so much, and we'll see each other again next time. Thank you.